I think the three main drivers of cost of machine learning projects are how available is data, how accurate do you need the system to be, and then how difficult is the problem overall. And so the main things to think about here for data availability is, how hard is it to get data in the first place, but also how expensive is it to label? If you need expensive experts, it's going to be more expensive to label. If you can get labels automatically, it's going to be very cheap. And then just how much data will you need overall? For some problems, you can do well with tens of thousands of examples. For other problems, you might need hundreds of millions. For the accuracy requirement, I think there's a few things that influence this. One is how costly wrong predictions are, right? So if you make a wrong prediction in a self-driving car, you might kill someone. But if you make a wrong prediction in a recommendation system, then probably nothing really bad is actually going to happen. And then the other consideration here is how often does it need to be right to be useful, right? So for Alexa, if it doesn't work at least 90% of the time, for me at least, it's super frustrating, right? It's like not useful to me if it doesn't work 90% of the time. But maybe like Netflix's recommendation system, if it works half of the time, I'm pretty happy with it. And then problem difficulty, a couple ways to assess this. How good is the published work on similar problems? And then for that published work, does it require a ton of compute to train? And does it require a ton of compute to deploy? And so if you think about those things, then you can get a sense of how hard is this problem from a technical standpoint. Yeah, question in the back.
Yeah, at the first step, how do you know how much data you will need?
It's a great question. How do you know how much data you will need? I don't think that there's really one answer to that question. I think like the way I would probably approach this is I would try to find the most similar problems that people have worked on in published work, and I would look at how much data that they needed. There's a couple of rules of thumb that I use. I think like generally, very infrequently see deep learning systems work well with less than 10,000 examples. There are exceptions to that, but kind of a rule of thumb. And then for vision systems, I think things start to like really work well when you get in the hundreds of thousands of examples. So I want to zoom in a little bit on this accuracy requirement and just kind of explain why I think this is so important. So this is a chart showing the required accuracy of your project on the x-axis and the project cost on the y-axis. And the key point here is that like machine learning projects tend to scale more than linearly in the accuracy requirement. So like a heuristic that you can use is if you needed to add another 9 to your required accuracy, that could increase the cost of your project by like a factor of 10 or something like that. And so if you need many, many 9s of accuracy in order to be successful, your project is going to be very expensive. And the key example here, I think, is self-driving cars. So there's one thing that you can do, I think, to reduce the need for accuracy, and that's product design. So for example, like when I put a picture on Facebook, it doesn't just tag me automatically, right? The accuracy requirement for that would be really high, because if it tagged me wrong, I would be very offended by that. But if it just makes a suggestion, do you want to tag yourself, then it's kind of OK if that's wrong. This is a product called Grammarly. And Grammarly, I think, takes this one step forward, which is it doesn't only make suggestions, but it also gives you an explanation for why those suggestions are what is suggested. And so that, I think, even further reduces the need for accuracy, because you don't need to trust the system's recommendation as much. And then Netflix does something similar, right? It says, we're recommending this to you because you did something like this. And we don't really have time to go into this idea in that much detail. I think Jeremy will talk about some similar ideas tomorrow. And this is a blog post that I recommend if you want to read more about this. So there's one other heuristic for assessing the feasibility of machine learning projects that I want to mention. And this is an idea that many of you have probably seen from Andrew Ng, that pretty much anything that a normal person can do in under a second, we can now automate with AI. So I actually don't fully agree with this, but I think it's important to talk about it because it's something that you'll see. There are some examples of where this is largely true, right? So recognizing the content of images, understanding speech, translating speech, even grasping objects. These are all things that this is kind of a plausible claim, if maybe a bit of a stretch. But I think there are also a lot of counterexamples. Actually, like, does anyone have anything that they think is a good counterexample for this claim?
Assessing someone's character?
Assessing someone's character, yeah, that's great. Like, I don't think we know how to train a model to assess someone's character, but humans definitely do that, can do that in under 1 second. Yeah, in the back. I didn't hear you, sorry. Detecting negation in a sentence. That might actually be possible to do with modern language models. Yeah. Mm-hmm. Say it again. Falling in love. Yeah. Well, I don't know. I don't think anyone's really proved whether you can do that in less than 1 second. So I'm not going to count that one. Yeah. Matching two people. Yeah. That could be a good example. Some others I thought of are understanding humor and sarcasm. This is really easy for many of us. Probably not all of us, but many of us. And but it's extremely hard to do for computers still. In-hand robotic manipulation. So like being able to move my phone around in my hand. We've made a lot of progress on this at OpenAI in the last year or so, but this is still a very hard problem. Generalizing to new scenarios. You've never seen you've never seen me give a talk before, probably, but you kind of know how to react to that in some sense. And a system that has never been trained on me giving a talk before wouldn't know what to do. And I think there are many others. So again, I wanted to point this out because it's something you'll see, but I don't think this is actually a very good heuristic for assessing feasibility.